Welcome back, Leo Lions. This is Mrs. Morgan with our lesson today over expressions and how we combine like terms. So I have the topic up here in purple. We're getting into Bundle 2 today, and Bundle 2 has a lot to do with solving equations. Before we even begin equations, I wanted to make sure we know how to combine like terms in an expression. So I'm using some words here. If we don't know what an expression is, I wrote down here the things that you can find in an expression. So you can find numbers, variables, you can find a combo of those numbers and variables right next to each other. You can find operations, and then the major thing about an expression is there is no equal sign. Okay, when we get into equations, an equation has the word almost equal in it. So we're going to have an equal sign in an equation where we can solve it. An expression we cannot solve unless we know what the variable is. So if you could please write down these things, very important for you to know what an expression is. All right, so let's look at this example off to the right here. We have a big, long expression, 7x plus 3 minus 5x plus 8 plus 4x minus 1. That is what we call an expression, okay? So things we can find in an expression. We have variable terms. So variable terms or anything you can find with a variable in it. So this term here, 7x, 5x. Now notice in front of the 5x there is this minus sign, so I'm going to highlight that as well. And then 4x, and again I'm highlighting the plus sign in front of it. So these are what we call variable terms. 7x, I'm going to write down negative 5x, and then the 4x had a plus sign in front of it, so it's positive. We always look at the signs that are in front of the numbers. That tells us if they're positive or negatives. A plus sign and a positive, same thing. A negative and a minus sign, same thing. Okay? Constants are terms without a variable. So for example, we have the plus 3 here, plus 8, and then this minus 1. Those are all terms that do not have a variable on them, so we call them constants. So we're going to write down those examples. We have positive 3, positive 8, and then the 1 has the minus in front of it, so we consider that a negative 1. Okay, I'm also going to be using the terms coefficient. So the coefficients are the numbers that are in front of the variables. So the 7 in front of the x, the 5, but don't forget there's that minus sign in front of there, and then in front of the x over here is a positive 4. So the coefficients are 7, negative 5, and 4. Okay, I'm going to be using these terms quite a bit, or these words. And you're going to notice when we get into equations, it's going to be important that you know all of these words and understand what terms are, what like terms are, and so on, okay? So combining like terms, you can simplify an algebraic expression by combining like terms. This means to combine common variable terms and constant terms. So in that example we were just looking at up there, we have 7x, we have minus 5x, we have 4x. So we highlighted those at the top. We can combine all three of those terms into one term. So what we do when we combine them is then just look at the coefficients. So 7 minus 5 is 2, and then 2 plus 4 is 6. So we can combine those to 6x. Okay, then the next part we have our constants, our numbers that do not have variables on them. So positive 3, positive 8, and negative 1. So again, we just combine those. 3 plus 8 is 11, and then 11 minus 1 is 10. So 6x plus 10 is the exact same expression as we started with. If you notice, it's just a lot shorter. Okay, so let's look at some of these examples. I'm going to do some of them with you, and then I'm going to have you pause the video and you try them on your own. Okay, what we can do, if you noticed what I did in that example there, you can use different colors, you can use different shapes. Notice I underlined the terms that had the variable, and then I circled the constants. Or you could, like I said, use different colors, however you would like to show like terms. So let's look at 3x, and then this term also has an x. So 3x plus 6x, 3 plus 6 is 9, and then we want to have that variable x on it, okay? And that's all we have to do. Next one, 9a and then minus 10a. Both of those I'm underlining in the same color because they have the same variable. So 9 minus 10 is -1. -1a, we can write that without the 1. So negative a is the exact same thing as -1a. If we see a variable all by itself with no number in front of it, there's really an invisible 1 there. So that we're going to simplify it to just -a, okay? Now, let's look at this one. We have 7m minus 5m. Those both have the term m on it, but then this last term does not have a variable m on it, so it's a different term. We can't combine it in with the m's, okay? So we're going to combine 7 minus 5, so we have 2 m's. Now the minus 6 or -6, same thing, there's nothing we can combine it with. There's no other constants, so 2m minus 6 is simplified as far as we can go, okay? Next one, when we write these, if you guys notice, in our example we did up here with the 6x plus 10, and then this last example, 2m minus 6, you always write the variable first, and then the constants come last, okay? So if you notice in this one, I'm going to focus on the variable first. So we have 6w, and then don't forget there's a negative or a minus in front of there. There's no other w's in this expression, so that's all we have. Now, the constants, we have a 9. We know it's positive because there's nothing in front of it, and then also a positive 5. So when we combine these, the negative 6w we can't combine with anything. It's going to stay exactly how it is. And then the 9 plus 5 we can combine to a positive 14. So negative 6w plus 14, it's the exact same thing, just a little shorter than the expression we started with, okay? I'm going to have you pause the video here, and I want you to try 5 through 8 and stop after that, and then continue your video and see if you can get them correct, okay? I'm going to then continue here. Those combine to -2p, and then the constants we have are -1, positive 5, so that combines to positive 4. Right? Next one, h's, we have 5h and 7h, so those combine to 12h. And then our constants, we have -6, -8, so be careful. They're both negative, so we're going to add them and keep the sign negative, so -14, or 12h minus 14. Okay, now this example, I'm going to start out with my x. We have 5x. The 7y doesn't have the same variable, so I'm going to skip it. -x, and then plus 3x. Okay, then we have another variable. We have 7y, and we have 2y. Again, notice I'm taking the signs in front of them. If we have more than one variable, we want to put them in alphabetical order. So the x's, we have 5x. Now, remember, I just talked about if there's nothing in front of an x, there's really a 1 there. So minus 1x, that's 4x, plus 3x, so we have 7 x's. Okay, then with our y's, we have 7y plus 2y, so we have a total of 9y. So 7x plus 9y. And last one, we have 26a. I'm going to skip the next one, it has a b in it. We have -4a. And then the b's, we have 2b and 10b. So 26a minus 4a, we have 22a. And then 2 plus 10, we have plus 12b. Again, notice I put them in alphabetical order. All right. let's go to the next page. We're going to have some exponents here. The exponents, if we have terms with the same exponents or a combination of variables and exponents, they're considered like terms. But when combining, we do not want to change their exponents. So notice that we have x squared, and then the next one is also x squared. So we can combine them just how we've been doing. 5 plus 7 is 12, but we do nothing with the variable and the exponent. We just keep them the same. So 12x squared. All right, same thing with the next one. We have negative 15n. The exponents have to be the same in order to combine them. So these are like terms. So negative 15 plus 4 is negative 11. And then we keep the variable and the exponent. So negative 11 n to the 5th. Okay. C cubed. So we have 8c cubed. We have negative 7c cubed. And we have 16c cubed. So they all have the exact same exponent on them. So we can combine them all. 8 minus 7 is 1. And then 1 plus 16 is 17c cubed. Okay, now next one, we have 8k squared. Now the next one is just k. It does not have an exponent of 2 on it, so it's not a like term. Okay, but this last one here, negative 2k squared, that is a like term because it has the same exponent. Okay, same variable, same exponent. Now, next one, we have a negative k. Remember, that's negative 1k. We have a negative 5k. Those are like terms. And then lastly, we have a plus 7. It does not have a variable on it. It's not a like term with any of the others. So 8k squared, I'm going to start with my blue here. 8k squared minus 2k squared, so we have 6k squared. Negative 1k minus 5, so negative 1 minus 5 is negative 6k. And then the plus 7, we can't combine it with anything. There's no other like terms. So this one we end up with 3 terms in the end. 6k squared, negative 6k, and plus 7. All right, we can't combine anything else because they have to have the same exponents. Again, I'd like you to pause your video and challenge yourself and see if you could get the next 4 correct. All right. Now, these have multiple variables. So if you see a squared b, it has to be the exact same thing as that. So this a squared b down here does work. It has the same exponent here and no exponent on the b. Same exponent, none there. And then the plus 7 is our constant. So negative 4 plus 10 is 6. So 6a squared b. Remember, we keep the variables and exponents exactly how they are. And then plus 7. Right? We have x squared. Next term has x and y, not a like term. Same thing with that next one. And then y squared at the end, not the same variable. So x squared is all by itself there. Now, 2xy, we can combine with minus 7xy. They have the same variables, same exponents. And then lastly, this 4y squared. There are no other y squareds. Now, when we write this, we write them in alphabetical order, so your x squared comes first. We can't combine it with anything. Then plus 2x minus 7, so 2 minus 7 is negative 5. And then it transitions into the y squared. So plus 4y squared. And that's all we can do because the x squared and the y squared, they don't have any other like terms with them. Right? Kind of similar on this next one, a squared. There's no other terms that are a squared, so that's the only term like that. 7ab and then negative 10ab. Those are like terms because they have the same variables, no exponents on them. And then lastly, this b squared is all by itself. There's no other b squareds. So the a squared has to stay. 7 minus 10 on our ab's, so minus 3ab, and then transitions into our b squared. And that's the furthest we can go. Okay, and last one here we have 4x squared. Let's go through. We have minus 7x, x squared. Here's another x squared. I'm going to underline it. And there's no other x squareds. So I'm going to go to the next one. Here is a constant, a number all by itself. and here's another constant. And then 2x just has one variable of x, and then 8x also has a variable of x. So we want to start with the highest exponent, so the x squared needs to come first. So 4 minus 3 is 1. Remember, 1 we can write without the coefficient, so we're just going to write it as x squared. There's really an invisible 1 here, but we're not going to write it. We're going to simplify it. Okay, then let's go to the x's next. We always want constants to come last, so 2 plus 8 is 10x. And then our constants both have negatives in front of them. So -7, -6, we combine them, keep them negative. So -13. Okay. Last examples, here's some geometric applications where we just combine like terms. Perimeter, remember that means that we're going to add up all the sides. So we have 2x, 3x, and remember this is a 1x. So 2 plus 3 is 5, plus 1, we have 6 total x's. And then we have one constant, so plus 1. There is our perimeter. Okay, let's do it again over here. So we have, I'm going to start with alphabetical. So I'm going to do 5a. The 4ab doesn't work because it has a and b, not just a. But I do have a minus a right here. So these two guys can be combined. 5a minus a, so minus 1. We have 4a. Then we have AB over here. Remember, we're just adding them all together. Perimeter means this side plus this side plus this side. For AB, there's no other terms in there with an AB. It's positive, so we're going to write it as plus 4AB. And then our constants come last, so we have 17, that's a positive. Okay, and then a -1 or -1, so 17 minus 1 is 16, so we'll write it as plus 16. Okay, now this one, be careful because remember perimeter means all the way around, so if we only add those two, we will have forgotten this side is the exact same across, the parallel side, and then this side as well. So let's go through like terms. We have 3y here, a y here, so 1y, 3y, and a y here. So we can combine all those. 3 plus 3 is 6, plus 1 plus 1, so we have 8 total y's. Then our constants, we have a -5 and a -5, so that's -10. Plus 2 is -8. Plus 2 more is -6. So 8y minus 6. And last one, we have lots of terms in this one. Let's start with the highest exponent, so the k squared. So we have k squared, 2k squared, and k squared, okay? And that does take up, or does consider all 4 sides. So remember there's 1 here, there's 2, 3, 4, 5. So we have a total of 5k squared. Okay, let's go to the k's. So we have a -9k, a +1, and a +1 over here. So -9 plus 1 is -8, plus 1 more is -7k. And then our constants come last. So we have 23, we have -17, so that would be 6. And then the other two don't have any constants, so it'd be +6. All right. So that concludes our lesson of combining like terms. Underline them, find the things that are the same.